All right. Next is Solidity tricks. The developer panel. An update from NFT. It's by FrankNFT.eth. Right? This is Frank. You better know these tricks, man. You can get a lot of big bounty out there. There's plenty of money to be made, right?
Yeah, definitely. But oh, thanks, guys. The tricks are mainly about reducing gas, not finding bounties. But okay. So I'll quickly introduce myself. I came into the space about 2 years ago, starting Solidity. I did 30 years of development, backend development, mainly Java, stuff like that. And 2 years ago, I came into the space, and I did probably what everybody else was doing. Somebody asked me, we want a contract and we want to do a project. And I did what everybody does. I copied the Bored Ape contract. At that moment, that was already not a good decision anymore. And that is what this talk is about. So, first thing, don't use ERC-721 enumerable. It eats a ton of gas. It eats an extremely ton of gas because it's storing a whole lot of parameters on chain. So you can say, okay, let's use the ERC-721A. And I will say, no, let's not use that one. Why not? Well, what does the Azuki guys tell you? They say this is the cheapest contract to mint on. And that is 100% true. I will show later on a link to my GitHub. And we made all kinds of gas tests. And you will see that is 100% true. If you are minting 100, what is the Azuki contract doing? It is actually only minting token number 100. And the other 99 tokens, they just stay on the 0 address. And if you ask who owns token number 50, it just iterates over there. It sees, oh, the next one that was minted is 100. That's the owner. Okay, that's pretty cool. And it is absolutely the cheapest to mint. But what happens if I come in and I come to buy token number 50? Well, that same contract will do that same iteration. It will go looking to that token that was minted, token number 100. It will then come back to token 50, and it will mint it to the poor guy that is buying, and will then mint token number 49 back to me, because it has to stay consistent. So the small buyer is actually paying a ton of gas, because he's paying for 2 mints at that moment. And that doesn't go away, because that contract always has to do that check over and over again. So in the end, in the long run, the contract is actually not a low gas contract. It's just a good pro-whale contract if you mint 100. So when the A came out, I wrote an answer to it, and I was going to call it the ERC-721B. But people in my Discord, they said, Frank, come on, call it F. F stands for Frank. So we called it F, and yeah, there will be a link, a QR code at the end, so you can just go directly to the GitHub. It's completely documented. It wasn't a year ago. A year ago, it was just like 3 files, but now it's completely documented. You have all the examples you want, including even on-chain art and so on. So you can have a lot of fun with that, and it's all open source. So go copy-paste it. So let's see the 10 tips now. What have we done to make the F so good, so low gas? Well, first thing that as a Solidity dev you need to know is state variables. So if you have variables that you're using it more than once in your method, well, it is more interesting to actually copy it to a temp variable and just use it like that. If you know that your code, of course, is not changing that state variable. That will be more gas efficient. And of course, yeah, we're going down on the war for the for loops. And a very important here is array.length, because you're going to read your array.length all the time. So cache it out. You're not going to change the length of your array anyhow. So cache it out. But It's the war on for loops. We're not finished here yet. So this is where we were, right? What else can we change? Well, the incrementer. The incrementer here, it is using checked code. Since Solidity 8, there is actually code in there to see if that's not going to overflow, or not going to underflow. But basically, you're in a mint loop here. Is that going to overflow? Is that going to underflow? No, it's not. It's not going anywhere. So make it unchecked. And then, yeah, the last one, because yeah, we're building our mint method here. Okay, call it that, but whatever. That's where we are. And that's where we're going. If you're not changing your array for some reason, then make it call data. Because call data, the reads on call data, they're a lot cheaper than the reads on memory. Because, yeah, probably if you make a mint method of this, it would become an airdrop method. So you're just going to loop over all these addresses and mint something to these guys. You're not going to change anything. So make it call data. It's a lot more gas efficient. Okay, comparisons. Well, we already said it's an unsigned int. It's not going to go negative. So why should I do a require bigger than 0 if I can do a require not 0? We know it's not going anywhere. And the second one will, once again, use less gas. I really love this one. Swap magic. This is how we do it. Right? Who's the developer in this room? I forgot to check. Who's the developer in this room? Okay, I got a ton of developers. That's how you do a swap, right? Well, Solidity has a very, very handy feature, and it's called tuples. And with tuples, you can just swap like this. And this now means I don't have to make that temp variable, because that temp variable will once again cost me gas. So I can do it better using it like this. Use external when possible. So it's something, I do a lot of audits also on contracts, and it's something that developers used to forget a lot. We have external and we have public. External means anybody outside the contract can use it, but the contract itself can't use it. I can't call it from the contract itself or from contracts that are extending it. Public means anybody can call it. I can call it from inside the contract, or I can call it from outside the contract. The problem with this is whatever you're giving in as parameters will be copied over like this into new variables. Well, if you're using external, it's not doing that. So it's consuming less gas. Your mint method, you're probably never going to call it from the contract itself. Make it external. The optimizer, not really code here. You will find, if you go to the GitHub, you will actually find an Excel with all the tests and all the experiments that we did. And the optimizer I'm using Remix here. If you turn it on, we found that using 1000 is actually the optimal number. If you put it higher, you're not gaining anything anymore, and the code of your contract is just becoming longer. And if you use the default setting is 200, there's way more to optimize. So for mint contracts, we're going for 1000. Pack variables. Once again, this is not really for your user, but how does Solidity actually store on-chain variables? Well, it creates a sort of block, but it will, each time that it has a new type. And so here I'm mixing uints and a mapping. Each time you make a new type, it will actually create a new block. So with this code, I'm actually creating 3 blocks to store these variables. While if I do it like this, I will only create 2 blocks, because I will put the 2 uints together in one block. So this is for you as a developer. It's more, yeah, the deployer that will pay a little bit less. So it won't be less gas for your user, but it will be a little bit less gas for you as a deployer. And see, I have 20 seconds left. So here you have my Twitter. I'm FrankNFT.eth. I tweet a lot about projects, but also about code. My pinned tweet, of course, is my GitHub, but you also have the GitHub here, so you can actually go to the GitHub. You can steal all the code. You have all the examples, including on-chain. I'm not doing questions, but come to me afterwards, and I'll do the question. So just steal all the code, use it, and have fun with it. Thank you very much.
Well, you guys, now you know how to reduce your cost when you're deploying, right? Better use these things, okay?